Mr. Strauss is filmed before a live studio audience. Any rebroadcast of this may not be used without the express written consent of Mr. Strauss. All right, so with this diagram here, every line is an orbital. Okay, every line is described by a orbital graph. So yesterday we drew the 1s. So what's the graph of the 1s look like? Sphere. What does the graph of the 2s look like? Sphere within a sphere. What does the graphs of the p's look like? Our nice little dumbbells, right? And if we go up into the third energy level, sphere, sphere within a sphere, what's the 3s going to be? Sphere within a sphere within a sphere. You want to draw that, Lexi? No, that's too much. P's, these are dumbbells, right? So these would be dumbbells inside dumbbells.
Oh my god.
And then the d orbitals are nice little funky four-leaf clovers. Okay? So each line that I drew here is an orbital. The number of orbitals in each level is n squared. So n equals 1, I have one orbital, one line. N equals 2, what's 2 squared? 4. 1, 2, 3, 4 lines. 4 orbitals. 4 graphs. And we drew 4 graphs yesterday. Third energy level, n equal to 3. How many orbitals? 3 squared is 9. So I should have 9 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So the number of orbitals is equal to the energy level squared. Each orbital can hold 2 electrons. So if each orbital can hold 2 electrons, then the maximum number of electrons that can be placed into any energy level is 2n squared. So in the principal energy level, n is equal to 1, total number of orbitals are n squared. So that would be 1. How many electrons? That's 2n squared. So that would be 2. How about for the second energy level, or atom? How many orbitals could I put in there?
2. Oh, 4.
And how many electrons could be placed in there, Emmy? And the third energy level, how many electrons could go in, or how many orbitals could go in there, Ava?
9.
9, and this would be, what, 18, right? Any questions so far? All right, then, in the back part of your packet, you should see a sheet that looks like this. Make sure you have a pencil. If you don't have a pencil, then don't write on this sheet. Whoa. Okay, I'm gonna stop messing with it. All right, so just in case you were wondering, this is what we drew yesterday. That's the 1s orbital. That's what we drew. Sphere within a sphere, that's the 2s. This, sphere within a sphere within a sphere, that's the 3s. The dark parts are the nodes. Node in the middle, node at infinity. Node in the middle, node at infinity, node between the two spheres. So what this diagram shows us is the energy levels and the sublevels. So this whole black band is a level. The other parts are the sublevels. So in the first energy level, we just have the S sublevel. In the second energy level, we have the S and the P sublevels. So we have 2 sublevels. In the third energy level, we have 3 sublevels. Now, it's not quite aligned in a straight line, it's kind of more at a diagonal. And I'll explain why that is later. But in the third energy level, we have 3 sublevels, S, P, and D. There's only one S. There are always 3 P's. And they correspond to the PZ, the PY, and the PX. So what we're going to do is we're going to start to write out the locations where electrons are in different atoms. And there are some rules for doing this. And I'm going to flip back and forth between the rules and this chart. This chart will be very helpful for you in the beginning. Once you get it down, you probably won't need this chart anymore. So the rules for electron configurations is, the first rule is electrons prefer to be in the lowest available orbital. And that an orbital of lower energy must be completely filled before an orbital of higher energy can be filled. The Pauli exclusion principle, though, states that 2 electrons may exist in the same space as long as they have opposite spins. In other words, no 2 electrons may have the same 4 quantum values, and I'll explain what that means on Monday. But basically, is what this is saying is you can put 2 electrons in each orbital as long as they have opposite spins. So let's start with the simplest element on the periodic table, hydrogen. How many electrons does hydrogen have? 1. Now, where is the electron for the hydrogen atom? Where would be a good place to look for the electron in the hydrogen atom? Well, I suppose even before that, why do we even care where the electron is in the hydrogen atom? The reason why we care where the electron is because the electron controls bonding. Okay? It controls the behavior of the element. So if we know where the electron is, we will be able to explain why hydrogen is diatomic. We'll be able to explain why hydrogen forms a +1 charge. So that's kind of why we care, Karen, about where are these electrons and what they're doing. So the first rule is the electron must be in the lowest available orbital. Okay? So you can think of these boxes as levels on a shelf. So if you're gonna put books on a shelf, do you start at the top of the shelf? No, you start at the bottom of the shelf. So again, electrons are gonna be represented as half arrows. So where am I gonna put this electron? Into the 1s orbital. Now how do I write this out? It's in the first energy level, so I write the number 1. So that's the level. What sublevel am I in? The S sublevel. And how many electrons do I have? 1. And so that's a superscript. That tells me the number of electrons. Now let's go to, well, any questions before I move on to helium? All right, helium. Do it over here. How many electrons does helium have? 2. Okay, the rule is, now we're starting over. That's why I said use pencil. We have 2 electrons. The rule is, the first rule, number 1, is you've got to put your electrons in the lowest available orbital. So where's the lowest available orbital? Right there. So I put 1 in that box, spin up. Now what about the second electron? We've got 2 electrons. Well, rule number 2a says that you can put 2 electrons in the same box as long as they have opposite spins. So I put my second electron in there as long as it is spinning in the opposite direction, spin down. So now I write out my electron configuration for helium. I'm in the first energy level. What sublevel? The S. And how many electrons do I have? 2. Lithium. Erase and we start over. Three electrons for lithium. Put them in the lowest available orbital first. Here's the first one. There's the second electron. And now where's the third one going to go, Kelly? Second. What's the next lowest box? The arrows tell us. The next lowest box is the 2s. And I just wrote it spin up. It doesn't have to be spin up. It could be spin down, okay? It's just that when you have 2 of them in the same box, one must be up, one must be down. So then our configuration would be, there's 2 in the 1s, 2. And then where's the next electron? In the 2s1. We call this the electron configuration. It is telling me where my electrons are. Any questions so far? Okay, now I didn't hand out this orbital diagram worksheet yesterday, did I? To you guys. You have one, right?
No.
Okay, just kidding. So for homework tonight, you have to do worksheet 5.2, which is in your packet, and also this orbital diagram worksheet. This worksheet will actually, my guess is you'll have it done by the end of class, because we're going to do a lot of these together right now. Okay, so let's take a look at this orbital diagram worksheet. Keep this thing nearby. So for the orbital diagram worksheet, you're going to be doing the electron configuration, the orbital diagram, and then writing the quantum numbers. We're going to save the quantum numbers probably till Wednesday of next week. We won't deal with that, but we're going to do these first two things. So how many electrons does hydrogen have? 1. The orbital diagram is filling in these little boxes here, okay? The rule is the electron has to go in the lowest level first. So I draw in my arrow. That's the orbital diagram, what I just did. Basically, it's just filling in the boxes. Writing out the 1s1, that's my electron configuration. Basically, this one is pictorial, that one is like a condensed form. So for helium, with 2 electrons, the orbital diagram would be, there's one in the s, and there's a second one in the s, as long as they have opposite spins. And so my electron configuration would be 1s2. Let's jump down to, well, any questions on 1 or 2? Then let's jump down to number 5. Okay, let's do boron together. How many electrons does boron have, Sarah? 5. Now, resist the temptation of trying to do this all right now on your own, because you'll end up doing some of them wrong. So stick with me here. Boron. So 5 electrons. So if we look back at our diagram, our 5 electrons could go 1, 2, 3, 4. Now where do we put the 5th electron? The 5th electron goes up into the 2p. But these 3 boxes are equal in energy. So there's a third or a 33% chance it'd be in the first box, a 33% chance it'd be in the second box, and a 33% chance it'd be in the third box. That 5th electron can go in any of the boxes. And it doesn't have to be spin up. There's a 50% chance it'd be spin up, there's a 50% chance it'd be spin down. So when it comes to doing number 5, this 5th electron could be in any of the circles. Normally, you just start off in the first box, and normally you put it as spin up, but you don't have to. So there's the orbital diagram. The electron configuration would be 1s2. How many are in the 2s, Ava?
2.
So that would be 2s2. And how many are in the p's? How many do I have in my p's, Quinn? 1. 2p1. So 1s2, 2s2, 2p1 is the electron configuration for boron. We'll do 2 more together. Let's do carbon and nitrogen. Carbon has 6 electrons. So, yep,
Can I get one of those sheets?
oh, sure. So once again, we go back to our sheet. Start from scratch. We have 6 electrons. Start at the bottom. 1, 2, 3, 4. Now I have 2 more electrons. And this is the third rule. The third rule is Hund's rule. When electrons are added to orbitals of equal energy, a single electron will enter each orbital before a second one may enter. In addition, the spins remain parallel if possible. Okay? So what that means is, the other way I've heard this described is, you put a kid in each bedroom before you start to double them up. I have 3 bedrooms. Okay? I put 1 kid in each bedroom before I would double them up. You don't put 2 kids in 1 bedroom if you have 2 spare rooms. Did your parents do that to you?
Yeah.
They did?
Sure.
Oh, I'm sorry.
Okay.
Sorry to hear that. Must have been traumatic.
It was.
But anyhow, normally you put 1 kid in each room. So you don't pair up the electrons if you don't have to. The spins must be parallel. They must both be spin up, or they both must be spin down. It doesn't matter, but they have to be either both up or both down. So my diagram would be 2 in the S, 2 in the 2s, and then 1 and 1. So my electron configuration would be 1s2, 2s2, and how many do I have in the p's? 2. So 2p2. And then for number 7, there are 7 electrons in nitrogen. Did I draw it out on yours? Yeah, I did. So you gotta have 1 in each. So you'd have 1 electron in each box before you start to double them up. So your configuration would be 1s2, 2s2, 2p, 3. And they're all either all spin up or they're all spin down. So we've done most of them, so you just have to do the rest of them. Do the electron configuration, do your orbital diagram, and then do worksheet 5.2. Okay? So like I said, you could probably get this worksheet done before the end of the hour. I'll come around and check to see if you're doing it right.